In R5, we're going to look at exponents. Now, there were some properties of exponents in section R2 that you see here. And they were our basic rules for exponents. The first one is the product rule. So whenever your bases are the same, and in this case, the base here is this value a, which could be a number or it could be a variable. When the base is the same and you're multiplying, all you do is you add the exponents together. So for example, if I have 3 squared times 3 to the third, that's simply going to equal to 3 to the 5th power, which I'm not going to multiply out. And I know this is pretty basic and you guys remember all this stuff, but just remember 0 exponent, anything not equal to 0. So as long as the base is not equal to 0, then if you raise it to the 0 power, it's just equal to 1. So 5 to the 0 power is equal to 1. Notice that 0 to the 0 power, that is not equal to 1. That's actually undefined. In calculus, whenever we see that, we call it an indeterminate form, and that just tells us whatever we're doing is not working, we have to try something else. We also have some other rules. These are our power rules. Anytime you have your base raised to a power, in parentheses, and raised to another power, you would just multiply it. So you can think of these parentheses as multiplication parentheses. So you would just multiply the exponents. So 2 to the 4th to the 5th is going to be 2 to the 20th power, which again I'm not going to multiply out. And then we have another rule that says whenever you have a product or multiplication inside the parentheses and it's raised to some exponent, then you can distribute that exponent to all the factors inside the parentheses. If I had 4 times 5 in parentheses, and I have that raised to the 3rd power, that would be 4 to the 3rd times 5 to the 3rd. And again, I'm not going to multiply those out. And then if you have a fraction in parentheses raised to some exponent, you can go ahead and distribute the exponent to the numerator and denominator, get rid of the parentheses. All of these rules have an equal sign, so they go both ways. So in one case, you can get rid of the parentheses, and that's usually what we want to do when we're asked to simplify. Simplify just means get rid of parentheses, get rid of negative exponents, reduce fractions, and so on. But you can also add parentheses, and we see this often when we factor. We add parentheses. So the last example of an exponential rule that we're going to look at for now would be like if you had a fraction 7/9 and you raised it to the 10th power, then that would be 7 to the 10 over 9 to the 10. In example 1, we're asked to simplify. When we're asked to simplify, we mean, hey, get rid of any parentheses, see if you can do any multiplication, make things basically just simpler. So I did want to bring this up. It's very basic. But the reason why I want to bring this up is because of the negative. The negative is outside of the parentheses. So this exponent 2 has nothing to do with that negative on the outside. This is the same as negative 1 times 4/5 squared, which is the same as 4 squared over 5 squared. You don't have to write all this. I'm just using the properties, which is negative 1 times 16 over 25. So the last step would be to multiply by that negative 1 to get negative 16 over 25. And you didn't have to do all of that. You could have simply realized that the negative would stay and you would just square the 4/5 to get 16 over 25. You didn't have to show all those steps. Again, I'm only showing it because I wanted to show how you use the properties. In part B, the negative is inside the parentheses. So negative 4/5 is a base to the exponent 2. So you could simply multiply negative 4/5 times negative 4/5, which is fine, but I'm going to use the properties. Inside the parentheses, I have a product. I have -1 times 4/5, and that's squared. So since I have a product, I can distribute that square to each factor within the parentheses to get -1 squared, 4/5 squared. So the -1 squared is simply 1, and then the 4/5 squared would give us a 16/25. So in the first example, the negative stayed. Second, the negative was gone. So just be careful with the use of negatives and parentheses. And then, of course, we don't have to have numbers. We can also have variables in there. Something that we want to do first is we want to say, hey, can we reduce or simplify within the parentheses first? And in this case, I can cancel the x top and bottom to get 4/5y squared. And then when I distribute that square, it's going to be 4 squared over 5 squared times y squared. So remember, you're distributing that square, that exponent 2, to both the 5 and the y. So you're going to get 16/25y squared. So let's move on to the actual properties that are in R5, and that would be our negative exponents, and then we'll go on to rational exponents. When we talk about negative exponents, we can always get rid of a negative exponent by flipping, and then the exponent becomes positive. In this example, we have our base a to the -n power. Remember, that's over 1. So to make the exponent positive, we simply flip the whole thing. So if I was to write 2 to the third, or -3, sorry. Again, I don't know what that means. Remember, what the exponent is telling us is how many times we multiply our base by itself. So this says I'm going to multiply 2 by itself -3 times. Makes no sense. The only way it's going to make sense is if I make that exponent positive by flipping and making it 1/2, now, or 2 to the third, sorry. So now I actually know what that means. I know that 2 to the third is 8. So this is 1/8. So again, flip, exponent becomes negative, but then look at if it's positive and you flip, then you make it negative. So anytime you flip, exponent will change from negative to positive. And then we have our next rule, which is a quotient rule. Whenever you have the same base and a fraction in the numerator and denominator, you would just subtract the upper exponent minus the lower exponent. And this is assuming that the denominator is not 0. So we'll use those properties. In example 2a, just be careful that you don't flip everything. Notice the 7 does not have exponent that's negative. It's 7 to the +1, so that stays. That's fine. It's the 2 that we have an issue with. So we're going to flip it down below and make it a +3. So that will be 1/7 times 8, which would be 1/56. All right, now let's look at B. In part B, your textbook will tell you to, I don't want to do this because it's so wrong. It's correct, but it's making it harder than it has to. The textbook will say, to make the -3 exponent positive, you have to put 1/2 to the 5th to the +3. And that is true, absolutely true. But why make it harder than you have to? Remember, to make a negative exponent positive, you flip. You flip everything. So if it's 2/5 and I just flip it to 5/2, then that -3 will become a +3, which in turn will become 5 to the third, which is going to be 125, and I won't write that out. And then 2 to the third becomes 8. So the reason why I can do that is because if we looked at the other property where we would take 2/5 to the -3 and distribute and get rid of the parentheses, then you could see that the 5 would come up, positive 3, 2 would come down, positive 3. So the shortcut is if you have a fraction in parentheses to a negative exponent, just flip the fraction, make the exponent positive. You don't have to do what they do in the book. All right, let's see. Part C. I could take the y to the negative 2 and make it positive by flipping it down, but I think I am going to first get rid of the parentheses. So I'm going to leave the x, y to the negative 2 the way it is. And instead I'm going to take the exponent 2 and I'm going to distribute it to this product on the inside. So when you distribute that exponent, remember you're multiplying exponents. So this 3 to the negative 1 becomes 3 to the negative 1 times 2, which would be negative 2. And then we have the y squared. I'm going to rewrite this with 3 to the negative 2, so number, and then I'm going to write my variables alphabetically, so x, y to the negative 2, and y. Sometimes it's nice to see the like terms side by side. I can see, oops, I forgot my square on this y, sorry. I can see with these y's that I can combine them because I'm multiplying same base. I'm going to add the exponent, so that would be y to the 0. And I could see that I have a negative exponent on the 3, so in one step, I'm going to write this as x, y to the 0, and bring down the 3 and make the negative 2 exponent positive. And of course, anything to the 0 power is 1, so this is just going to be x over 9. Now we're going to talk about our rational exponents. So again, when we say rational, it's ratio, which would be a fraction. So these are our exponents that are fraction exponents. Let's go over a very simple but complex idea. When we look at some base a to the fraction or rational exponent 1 over n, it really makes a difference because this is a fraction. What's in the denominator? Okay, so clearly n can't be 0 or else this would be undefined. But we have to be careful whether n is even or odd. So this is what's in the bullets below. Let's say that n is even and our base is greater than or equal to 0, so our base is not negative. Then we have this cancellation property that says a to the 1 over n to the n power will cancel, and we just get a. The reason why is because a to the 1 over n, and if we get rid of the parentheses and we use one of our prior rules, we would multiply by n, or n over 1, just gives us a to the n over n, which would be a to the 1, which is simply a. But that is provided that a is not negative. And that's because this would be an even number in the denominator of that fraction. Now, we're not going to talk about this until the next section, but remember something like a to the 1/2, that's actually the square root of a. So whenever you have even n in the denominator, you have to be careful that you don't get a negative, okay, base. But let's say that n is odd, like 3, 5, 7, 9, or whatever. And then we don't have to be careful. It doesn't matter what the base is. If we take it 1 to the n to the nth power, these will cancel and you just get a. So something to think about. And then we have this property with rational exponents that says if you have a rational exponent, you can break it up in 2 different ways, because remember that this m over n is the same as m times 1 over n. So we can break it up with a to the 1 over n to the power of m on the outside of the parentheses, or a to the m to the 1 over n power. And we can use these rules whenever we simplify. So if I wanted to simplify 8 to the 1/3, just using these properties, now I already know that's going to be 2, because that's to the 1/3 power is the same as saying the cube root of 8. but we're not talking about radicals yet. So if I was just using these powers, I would rewrite 8 as 2 to the third. So I'd get 2 to the third to the 1/3 power, and then n is 3, it's odd, so no restriction there. These would cancel, and that would simply be 2. Okay, again, I'm just using the properties in this section. I know there's easier ways to do this. In part B, I have negative 32 to the 1/5 power. 5 is odd, so it's okay if I have a negative base, negative 32. But I want to use the property, so I'm going to rewrite negative 32 as negative 2 to the 5th power. And then that's raised to the 1/5 power. And then I can use a property. These will cancel, and my answer is negative 2. Let's do something a bit more challenging. In part C, let's see, there's a lot of things we could do. It's not simplified because there's some negative exponents. We want to make them positive. So I could flip the m's. Another thing I could do is I can combine all those 7s because they're all common bases. So I think what I'm going to do first is I'm going to combine in the top these 7s. Maybe I will make the m's positive, or maybe not. Maybe I'll leave them the way they are. So if I were to combine same base, what we're going to do here is we're going to add our exponents, right? So it's 1/3 plus 2/3 is 3/3, which is just 1. So this becomes 7 m to the negative 2 over 7 to the third m to the negative 3. And then from here, I could, this is 7 to the 1 power. Now I see right away that I can take away 1/7 from the numerator and 1/7 from the denominator, and the denominator would just be 7 squared. I can see that. But I'm going to use these properties. I'm going to actually use the fact that you would take the upper exponent minus the lower exponent. And I'll do that with the m's as well. M to the negative 2 minus negative 3. That will give me 7 to the negative 2, m to the positive 1, because this is negative 2 plus 3, which would be 1. So now the only thing I have to do is get rid of that negative exponent by dropping the 7 into the denominator and making it a positive 2 exponent, which in turn would be m over 49. So using the properties, you oftentimes have different choices on how you're going to approach it, and it really doesn't matter. As long as you're using the properties correctly, we'll all get to the same place. Let's look at another one. This one looks pretty ugly. So again, I have choices. Within the parentheses, I can make the exponent on y positive by bringing that up, or I can get rid of the parentheses by distributing that 1/5 exponent on the outside of the parentheses. I'm going to choose the simpler one. I am going to bring the y up and make it y to the 5/2 over 32. There's nothing else I can do within the parentheses, so I'm going to get rid of them by distributing that 1/5 exponent. So when we distribute, remember we're multiplying exponents. So the x is going to be 10 over 5. The y is going to be 5 over 10. Normally I wouldn't write this. I would just write x squared and y to the 1/2. But remember that 1/5 exponent also goes to the 32 in the denominator. Again, oftentimes people forget that. This would be x squared, y to the 1/2. And 32 is 2 to the 5th. So 32 to the 1/5 is simply 2. So I'll write that out. 32 is 2 to the 5th raised to the 1/5 power. The 5th and the 1/5 cancel, and I just get 2. We get x squared, y to the 1/2 over 2. And let's move on to one more example. Example E we have these parentheses that contain a subtraction and an addition. Now these aren't binomials because they're not polynomials. Polynomials don't have rational exponents, but they do have two terms. What we need to do to get rid of the parentheses, because again it's not simplified with parentheses, is we need to just distribute. The n to the 1/3, we're going to multiply that by n to the 5/3, and then n to the 2/3. When I distribute the n to the 1/3, and I'm not going to just say that this is n to the, what's it going to look like? It's not, it will be n squared, but it's kind of hard to see with fraction exponents. So I'm just going to write it out. This is n to the 1/3 times n to the 5/3. And then we're going to distribute it to the next term, which is positive, so it's still going to be positive, n to the 1/3 times n to the 2/3. Now let's go ahead and distribute the negative, right? There's a negative here, n to the 2/3. So that's going to go to the n to the 5/3 and then n to the 2/3. That's going to be a minus n to the 2/3 times n to the 5/3 minus n to the 2/3 times n to the 2/3. I got rid of the parentheses. Now let's go ahead and combine. We are multiplying with the same base, so we add our exponents. This is going to be n to the 6. I said 3 and I wrote 2. Why do I keep doing this? This is going to be n to the 6/3, which in turn would be n squared, plus n to the 3/3, which in turn would be just n, but I'll write it out, minus n to the 7/3, minus n to the 4/3. And then I'm going to go ahead and simplify those exponents to write n squared plus n minus n to the 7/3, nothing I can do there, minus n to the 4/3. Again, nothing I can simplify there. And that's it. So let's go to the next thing. And then the last topic we will cover in this section is how to factor with negative or rational exponents. So the key here is that whenever you are factoring and you have negative or rational exponents, you always choose the smallest exponent when you're factoring out. In example 4a, I have n to the negative 3 minus 4n to the negative 5. I can see that I have this common n in both of my terms. So I know I can factor out an n. I'm going to choose the smallest exponent, which would be the negative 5. And then what remains will be in parentheses. So remember what we're doing. When we're factoring out, we're dividing each term by what we're pulling out. So I'm actually dividing by n to the negative 5, n to the negative 5. And by our properties of exponents, remember that's subtraction. So in the first term, it's going to be n to the negative 3 minus negative 5, or n to the negative 3 plus 5. And in the next term, the negative 4n to the negative 5, I'm dividing by n to the negative 5, so you can see that that would be n to the negative 5 minus a negative minus a negative 5, so that's going to be n to the 0, which is just 1. But you can see with this division that that just cancels, so you just get 1. Oops, you get 4 because it had the coefficient 4, apologies. Now this becomes n to the negative 5 on the outside, n to the negative 3 plus 5 would be n squared minus 4. And that's factored, but is it factored completely? No. N squared minus 4 is the difference of squares, so it's n plus 2 and minus 2. And then also that n to the negative 5, I can make that exponent positive by dropping it below into the denominator. That is completely factored, and it's also simplified because I made the negative 5 exponent positive. Let's try another one. In part B, we have 3 terms, and I can see every term has an x in it. So I know I can factor out an x. The exponent I'm going to choose would be a -1/2 because that's the smallest. So what remains is in parentheses. So remember what we're doing is we're dividing by x to the -1/2. And I could see in this last term that the x to the -1/2 will cancel, and I'll just have the +2. The x to the 3/2 divided by x to the -1/2 would mean 3/2 minus a -1/2, which would be x to the 3/2 plus 1/2, right? Because it's going to be a minus negative. Oops, and then we have a minus 3x to the 1/2 minus a -1/2 would be 1/2 plus 1/2. And then we have this +2. So it becomes x to the -1/2. Within the parentheses, I have x to the 4/2 or x squared minus 3x plus 2. This is factored. Is it factored completely? No. Within the parentheses, this can factor to a -2 minus 1. And then I can drop the x below and make it to the positive 1/2 power. So now it's completely factored, and I no longer have negative exponents as well. I got a really loud rooster outside. This is our last example in this section. I have 2 terms. Within those 2 terms, in the parentheses, we have the same x plus 3x plus 3. So as we did in a previous section, you could simply do a substitution on the x plus 3 and then see what it looks like. That might be easier to do. Or you could factor out the x plus 3. But what I'm going to do is I'm going to do a substitution. I'm going to let y equal x plus 3. And then that would mean that this is equal to y to the 5/3 minus y to the 1/3. That looks much nicer to me. And then I could see that I have this common y that I could factor out. The smaller exponent would be, this should be -1/3, sorry. -1/3 should be the smallest exponent. I have an issue with talking and writing. Now when I factor out y to the -1/3, remember what we're doing. We're subtracting a -1/3, so we would have y to the 5/3 minus a negative, so plus 1/3. And this would just be a -1. We have y to the -1/3. In the parentheses, we have 6/3, which is 2. We have y squared minus 1. And I can see that I can factor that as y plus 1, y minus 1, using difference of squares. And I can drop the y below and make it a positive 1/3 exponent. So that's completely factored, no negative exponents. However, we started with x's, not y's. So I still need to substitute back x plus 3 for my y. And I will have x plus 3 plus 1. X plus 3 minus 1 over parentheses x plus 3 to the 1/3. And then within those parentheses in the numerator, I can simplify that to x plus 4, x plus 2. And then denominator is x plus 3 to the 1/3. Okay, that is completely factored, and I have no negative exponents. So that's it for this section.